Irodov problem number 61. So in this problem, we have two bars or two blocks, 1 and 2 of masses m1 and m2, and with coefficient of frictions k1 and k2, and they are sliding on a rough inclined surface. And the object of the problem is, first we have to find the force of interaction between the two blocks, that is the pressing force between the two blocks. First, we have to find the force of interaction between the bars or blocks, and then we have to find the minimum value of the inclination angle alpha, for which the blocks will start sliding down the inclined surface. Okay, so this is the description and goal of the problem. Now, if we go for the recap of little bit of fundamentals which we covered in Newton's law, when a block is sliding down on a rough inclined surface, okay, if we recap the fundamentals, so suppose we have a rough inclined surface and a block is sliding down that surface. We have a rough inclined surface, so of angle theta, and the block has a mass m and it is sliding down with an acceleration a on the rough inclined surface. Okay, so we have seen it is also coming down with a velocity v. So we have seen in the fundamental, when the block comes down with a velocity v and has an acceleration a downward, then the value of a was g sine theta minus mu cos theta, correct? That was the value of acceleration down some inclined surface that we have covered in the fundamentals of Newton's law. Okay, now see, very straightforward, this mathematical relation tells you higher the value of mu, lower will be the value of a, correct? Higher will be the value of mu. This tells us that higher will be the value of mu, so lower will be the value of a. Simple, straightforward, because it is a subtraction of mu cos theta. So if you are increasing mu, a will decrease. Okay, so this is one of the fundamental thing which we covered in Newton's law, which we will apply in this problem. Now suppose we have two blocks. Suppose we have two blocks which you are releasing side by side on some rough inclined surface. So this is your block 1 of block 1, the mass is m1, and there is a block 2 of mass m2. And here the coefficient of friction is mu1, and here the coefficient of friction is mu2. Okay, and this is a, of course, rough surface, then only mu will be non-zero. Now we have case if mu1 is not equal to mu2, so both the block will have different acceleration to come down. They will have a tendency of different acceleration to come down the inclined surface, correct? So see case 1. If mu1 is less than mu2, if mu1 is less than mu2, then of course by this logic, a1 will be greater than a2. That means in this case, when mu1 is less than mu2, a1 will be greater than a2, that is a block ahead. Block ahead is block 1. It will have a greater acceleration. It will have a greater acceleration to come down, a1, and there will be no interaction force between the blocks. They will come with different acceleration. A1 will be greater than a2. Block 1 will be leading block 2. Okay, the distance will be increasing between them, because in this case a1 will be greater than a2 when mu1 is less than mu2. That is the case 1. Now see the second case. If you see the second case, case 2, if mu1 is greater than mu2, so if mu1 is greater than mu2, and if they were to come independently, separately, then a1 would have been less than a2, correct? If they were coming separately, independently, then a1 would have been less than a2. But in this case, since you are releasing them side by side, you are releasing them side by side This is 1 and 2. And in this case, block 1 has a tendency of lesser acceleration and block 2 has a tendency of greater acceleration, due to which block 2 will press block 1. Due to which block 2 will press block 1 with a pressing or interaction force, say R, and by Newton's third law, block 1 will press block 2 with an equal and opposite force R, and they will be in contact, and they will come down with a common acceleration A. They will come down with some common acceleration, say A. Okay, say angle theta. When mu1 is greater than mu2. So these are the two cases. So whether they will come down with different acceleration or with same acceleration, some common acceleration, it will depend on the relative values of the coefficient of friction. That is the background. Okay. Now let's see what is the subject of the present problem. In the present problem, we are being told that K1 in this problem, instead of mu, in the Irodov, it is given K. So of course we will understand K in place of mu. So K1 is greater than K2. That is the coefficient of friction of 1 is greater than the coefficient of friction of 2. It means this case will be applicable, correct? This case will be applicable. So your block 2 and block 1 will come down with the common acceleration, correct? So we have seen in the present problem, both the blocks would be accelerating together with some common acceleration, correct? So in the present problem, I can represent, say this is block 1 and 2, and say A is the common acceleration of both the blocks, since mu1 is greater than mu2. So both will come down with common acceleration, okay? And if I'm making different forces, so there will be a normal force N1, this will be N2, and 2 will press 1 with a contact force, say R, and by Newton's third law, 1 will press 2 with a contact force R, and its weight of M1, M1G, its weight of M2, M2G. Okay. Now suppose if you have to find the value of A, then you can also make the combined FBD. The condition for the combined FBD is that all the parts of the system must have the same acceleration, which is surely met in this problem. Both the blocks are having the same acceleration, so we can make the combined FBD for finding A. But if you are finding R, then the combined FBD won't work, because as we know, for the combined FBD, R will be an internal force. So if you want to find the value of R, we have to make the individual FBD. So what I'm going to do, and of course by individual FBD, A2 will come, but by the combined FBD, only A can come. Then for finding R, we have to decompose and make the individual FBD. So since we have to find R, so we are going for the individual FBD. So I'm making the FBD of both the blocks. So first I'm making the FBD of block 1. First I'm making the FBD of block 1. FBD of M1, okay? So let us make the inclined plane in a dotted form, because my subject is not the inclined plane. So this angle is theta, and this is your M1, and the different forces will be, one is the normal reaction, one is the weight, one is the pressing force, the force of interaction or the normal force on M1 by M2 R, and one is the frictional force F1, and this is your A, okay. Now I can take the coordinate system for resolving the forces. So one axis I'm taking perpendicular, and another I'm taking along the inclined surface. So this I labeled as axis of Y and axis of X. Of course, I have to resolve NG. It is on none of the axes. So as we know, this will come to be M1G cos theta, and this will have a component M1G sin theta, correct? Now, if you see on the y-axis, there is no motion on the y-axis. The equilibrium is maintained perpendicular to the inclined surface. So net force on the y-axis is N1 minus M1G cos theta, and AY will be 0. So let's apply Newton's second law on the y-axis. So I'll get N1 minus M1G cos theta will be 0. Therefore, N1 comes to be M1G cos theta, okay? This is the value of the normal force. This is the value of the normal force on block N1 by the inclined surface. See, I did the complete working in writing all steps of Newton's law. You could have also done simply shortcut approach. There is no motion on the y-axis, so net force on the y-axis would be 0. So N1 must be balancing M1g cos theta. So you can also write directly in case of MCQ, but we are going for the complete working, so that's why I'm writing each and every step. Now, what is the net force on the x-axis? So I will get R plus M1g sine theta minus F1, and AX is A. So if I apply Newton's second law on the x-axis, so I will get sigma fx is max. So I will have R plus m1g sine theta minus f1 is m1a. Now I can put the value of f1. F1 is the frictional force. Okay, F1 is the frictional force. So put the value of F1. So F1 is the coefficient of friction, which is given in case K, and K1 multiplied by N1, and N1 is M1g cos theta. So it will be K1 M1g cos theta. So you'll get the equation R plus M1g sine theta minus K1 M1g cos theta is M1a. Let it be equation number 3. Okay. So that you got an equation in R and A by the FBD of first block. This is how we obtained an equation in R and A by the FBD of first block. Okay. Now let us go for the second block. So if I'm making the FBD of second block in the similar manner, everything will be identical. The value of forces will change. So if I'm making the FBD of M2, so again I would like to represent the inclined as a dotted surface, and let us label all the forces. The inclination is theta, and this is your M2. So one force will be the normal force N2 by the inclined surface, another will be the weight, friction will act upward, say F2, normal reaction or pressing force by M1 will act upward, R, and the acceleration is downward, A. Now again I will take the two axes systematically. So this I'm taking x-axis, y-axis, and then I will resolve the component. It will M2g cos theta, and it is M2g sin theta, correct? So again the net force on the y-axis will be 0. Directly you can say कि N2 will be equal to M2g cos theta, but I'm going again for the systematic approach. Sigma N2 is N2 minus M2g cos theta, and AY is 0, no motion perpendicular to the inclined surface. So Fy is MAY. So I'll get N2 minus M2g cos theta will be 0. So N2 will be equal to what? M2g cos theta. So this is the value of N2. Now what is the net force on the x-axis? So net force on the x-axis is M2g sin theta minus R minus F1, and AX is A. Now let's apply Newton's second law on the x-axis. So I will get M2g sin theta minus R minus F1 is M2A, correct? No, sorry, F2, not F1. Here it will be F2. That is the second block. So M2g sin theta minus R minus F2 is M2A. And what will be F2? The coefficient of friction for the second block, N2 multiplied by N2, K2 into N2. K2 is the coefficient of friction, and N2 is given M2g cos theta. So it is K2 m2g cos theta. Put this value of f2 in this equation. So you will have the equation m2g sin theta minus r minus k2 m2g cos theta is m2a. Let it be equation number 4th. So you got another equation. You got another equation in terms of r and a. Okay. So if you see from the FBD, of the two objects, we got two different equations, equation number 3 and equation number 4. And both the equation involve two parameters, r and a. Now we have some mathematics. The point is that what quantity we need to find out and which quantity need to be eliminated. So say you can find both. You can eliminate r and find a, or you can eliminate a, find r. So let's decide the goal. So my goal is first to find r, eliminating a. Okay, my goal is finding r, eliminating a. That is my mathematical goal. Find r, eliminate a. Or something we have simple mathematics, nothing else. So there are so many ways for eliminating a. What you can do, you can make a as subject in this equation, you can make a as subject in this equation, and you can equate both a's, both the values of a in equation 3 and equation 4, and you will get r. One way is to make the coefficient of a same in both the equations. That is something very basic which you have been doing from childhood. If you want to cancel some term, make its coefficient same, and that term will get cancelled away. So I'm going for that approach. I want to make the coefficient of a same in both the equation. So here it is m1, here it is m2. So let me multiply equation 3 with m2, and I will multiply equation 4th with m1. So I am multiplying equation 3 with m2. So what I will get? I'll get r m2 plus m1 m2g sin theta minus k1 m1 m2g cos theta is equal to m1 m2a. Let it be equation number 5. Now in the same manner, what we can do, I can multiply equation number 4th with m1. So what I'll get? m1 m2g sin theta minus r m1 minus k2 m1 m2g cos theta is equal to m1 m2a. Let it be equation number 6. Now you got two equations, two new equations in which the coefficient of a is same. So if you subtract both the equation, this RHS term will get cancelled away. So if I'm subtracting, so this will become negative, this will become positive, this will become positive, this will become negative, correct? So this will get cancelled away, and I will get what? I will get r m2, correct, plus r m1, and sin theta factor will come to be m1 m2g sin theta, m1 m2g sin theta. That will make, this is minus and this is, so this will also get cancelled away, m1 m2g sin theta, m1 m2g sin theta. This is a plus sign, this is a minus sign, and this is k m1 k1 m1 m2g cos theta, and this will be plus k2 m1 m2g cos theta. So I can take m1 m2g cos theta as a common factor, and this will be a plus sign, so you'll get k2 minus k1 will be equal to 0. This will be your subtraction result. Okay, now what you need to do, you need to make r as the subject. Simply make r as the subject. So if I'm making r as the subject, so we'll get r m1 plus m2 will be equal to negative of m1 m2g cos theta k2 minus k1. So you can write r as what? You can reverse the order for removing the negative sign. You will get m1 m2g cos theta k1 minus k2 divided by m1 plus m2. So you got this value of r. That is your answer to first part. That is your answer to first part, the force of interaction between the two blocks. This is the answer to your first part, the force of interaction between the two blocks. Okay. Now the second part of the problem says, what is the minimum value of the angle alpha? Okay, it is given alpha. I got the answer in terms of theta. Of course, you can replace that in terms of alpha, no problem. We worked with assumption of theta. In the problem, it is given alpha, so that is not the big issue. Simply you can, in place of that theta, you can write the value of alpha, correct? Now, second object of the problem is that, okay, what is the minimum value of alpha at which the bars start sliding down? So you have to find what will be the minimum value of this alpha for it will start sliding down. Okay. So what will be the approach? What will be the fundamental for this part? First, find the acceleration, the expression of acceleration in terms of alpha. And for minimum value of alpha, this acceleration will be 0. Okay, so for the second part, the goal is to first find the common acceleration in terms of alpha, and then for minimum value of sliding alpha, we will put a to be 0. So now again we'll go to that pair of equation. Which equation? We got these two equations, equation number 3rd and equation number 4th. Same, equation number 3rd and equation number 4th. And now we have to find the value of a. Now a goal is to find the value of a, and we have to eliminate r. So simply we can add equation number 3 and equation number 4, and r will get eliminated, correct? So I'm writing it this side just for simplicity. So now what I'm going to do, simply adding both the equation. So adding equation number 3 and equation number 4. So when you add up both the equation, what you will get? See, r will get cancelled away. You will get m1g sine theta plus m2g sine theta minus g cos theta k1 m1 plus k2 m2 is equal to m1 plus m2 multiplied by a. So a will come to be, you can take g sine theta as a common factor, g sine theta, and g you can take in altogether common, m1 plus m2 minus cos theta k1 m1 plus k2 m2 divided by m1 plus m2. So this is the value of your common acceleration of the two blocks. This is the value of your common acceleration of the two blocks, which is coming in terms of theta or alpha, whatever the angle may be. I'm writing in theta. In problem, it is given alpha. Now you have to find that minimum value of alpha or theta for which the blocks will start sliding. We have to find the minimum value of theta or alpha for which the blocks will start sliding. Okay. So for minimum value of angle theta for sliding, the concept will be, we will take the acceleration to be 0 at the verge of sliding. Just for sliding case, we will take the acceleration to be 0, correct? So put a to be 0. So this is a non-zero quantity g. This is 1 by m1 plus m2 will not be equal to 0. So this factor must be 0. So we'll get sine theta m1 plus m2 minus cos theta k1 m1 plus k2 m2 must be equal to 0, correct? So you will get sine theta is equal to, divided by cos theta is k1 m1 plus k2 m2 divided by m1 plus m2, and this is what tan theta. So your tan theta will come to be k1 m1 plus k2 m2 divided by m1 plus m2. So this is the answer for the required minimum angle for which the sliding will take place. In your case, in the problem, instead of angle theta, it is given alpha. So simply write alpha k1 m1 plus K2 M2 divided by M1 plus M2. And of course, if you need to make alpha as the subject, write in the tan inverse form. So that is the answer to the second part of the problem. Okay. So that is how we did this problem. Irodov, problem number 61.